I think the main idea here, it's iterations, right? I went through different versions of this, and that's what I think is key about any type of 3D design is you can just put these pieces in here, you can make slight adjustments, print out the physical object, see if you like it, and move on to the next one. Today I want to talk about a project I've been working on for a while now. It has to do with these document cameras, the HoverCam. HoverCam makes the document camera. They make several different versions. This is the Solo 5. But what they sell is this little HoverCam adapter. It is an adapter that then mounts onto the end of the HoverCam. So we put it here, and it just clicks onto there in place. And then when you have a microscope, you can then, of course, project what you are going to be looking at through the microscope. This part here actually costs it costs $20 on their website. And you can purchase it. And the thing is, not everybody needs one of these. So I just kind of threw it out there on Twitter to HoverCam, and I said, hey, some schools might have 3D printers. Could we 3D print this part? Do you have the model for it? And they were like, well, I think they didn't have the model, but they said, go ahead and try to, if you have one, go ahead and design one, let us know. So I was like, all right, challenge accepted. So what I did is I started off with just my calipers and, just did some measurements and wrote it down and just kept recording and writing and writing and writing and started with some sketches there. I messed around first in Tinkercad, but this project then got me to use Fusion 360. And I'm glad I learned about Fusion 360 because the other app that Autodesk makes, 3D 123, or what is it? 3D 123, it doesn't matter, it's gone anyways. So Fusion 360 is what got me to the very first part that I made, which is this one right here. Now the interesting thing about this part is it was just totally a prototype. It doesn't have any little locking ridge on the top here for me to kind of grip onto the HoverCam. So if you compare it to the original, wherever I just threw that, the original has this ridge on here, and that little ridge then can grab onto the sides of the HoverCam and pop into there quite nicely. It is a little bit hard to get off of there, and that was one of the criticisms, especially if you have the HoverCam, and if your version of the HoverCam doesn't have this little flip-flop dial. Some of the HoverCams, our Solo 8s, have these little vent things here instead. They don't have that flipping feature, and when you put this guy on here, it's much harder to get off on, especially if you haven't done it right away. So my first challenge was to just try to straight up replicate that, which I did right here. I just made a kind of a complete copy of it. One of the concerns though is that when you're making this one, it has overhangs. So I printed it off the bed like this, but then you can see this little part right here is an overhang, and I had to use supports there so it didn't kind of droop. And I did the same thing under here. This is the shaft where the part where it fits onto the eyepiece. Well, that I had to use, because it is an overhang, I had to use supports. And that kind of got a little gunked up under there, and it's just rough and it wasn't very good. But I just wanted to see if it worked first. Then I moved from this part to this one here, which added the little ridge on there. So that ridge then was allowed to snap onto the HoverCam. So that was the next piece. And then to solve the support issue, I got to making this piece right here. What I did with this is just by putting what's called, in Fusion 360 you can do what's called a fillet, and it basically just takes it and curves it over, and you can kind of control that. And that allows the 3D printer to kind of incrementally work its way out onto that side instead of having this big overhang and now I don't need to use supports. What's nice about this is I did the same thing on the inside. So I put the fillet in there, and this design now moved from a design here, which was probably like extruded plastic, to a design now that can be 3D printed. And it's a good lesson in the idea that you have to design for the type of manufacturing you're doing. And so in this case, because overhangs aren't so great for 3D printing, I changed the model to have a fillet. So I got some feedback from this one, and someone online said, hey, we like this. Could you make the shaft part here a little bit longer so that when it goes onto the camera itself, or onto the microscope itself, you can see that it's not that deep. It doesn't go in very far. So what they wanted is it a little bit deeper so it can snug in there a little bit better. That was really easy to do in Fusion 360, is you just extrude this out a little bit farther, and then you get this nice snug fit on there. I sent that part to them. They got a chance to take a look at it. What they struggled with was that it did not fit on here. They had the kind that we have, in which the ridges are on there, and it was really hard to get on and off, so that didn't really work for them. This version of the Solo 8 needs those little bumps, those little ridges on there. So I just had a straight groove across there. So again, another version. So if you look at the different versions I'm making here, I got all these different versions. I moved to this one here, in which I was able to put the little bumps on there. The little bumps then lock right into their tracks, their respective spots on the camera, and it was on there perfectly. So that, now this one works on both this one and this one. One of the criticisms about the original, though, is that it's sort of hard to get off sometimes, depending on the first time you've used it. It's hard to kind of, you got to use your fingers and pry it off of there, and that, whoa, that one just went flying. So what I did in this turn is I actually made a new modification to the design by putting this little piece right here, which is sort of a thumb pad now. And so that's like a little tab for us to pry and get on there, so you don't have to break your fingernails. So now I pop that in place. If I want to get it off, I can just push down with my thumb and it pops off easily. And if you're left-handed or right-handed, it doesn't matter, you just rotate it around. So that's just a little bit of tour of the design process and this whole project. It's really more about the design process. It's not really, you know, my love for microscope adapters, but the main idea is that I've went through 5 different versions of this microscope adapter, and it started with the original, and I could just keep making changes, and it doesn't take very long. You can just pop it into the 3D printer and off you go. And that's what I think is key about any type of 3D design, is you can just put these pieces in here, you can make slight adjustments, print out the physical object, see if you like it, and move on to the next one. It really takes you through that design process of changing and changing. So now if someone tries this and says, you know, I like this, but I want to make another modification, not a problem. I can open up the file, boom, 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 make a thing, spit it out of the printer, and off I go. I also just love the idea that, you know, this part is made now, I've designed it. Unlike something with like woodworking, this is just a file. I can just send it off to different printers and print more and more and more and more. I don't have to go through all the exact same steps. Now, from this point, the heavy lifting is done and the machine does the work. So that's just a little tour of this project I've been working on. I think it's a good example of the design process. Again, if you happen to have a Hovercam, I'll put the link in the description and you can download and print your own. If you do that, let me know what you think, how it turned out. If you have any modifications for me, comment and we'll see what happens. Thanks again for watching.